Good afternoon, everyone. My name's Peter Vigneux. I'm a senior Foundry engineer at Foxtrot. We're a Foundry deployment partner specializing in ensuring long-term success for our clients in Foundry. This involves a strategic partnership, scaling workflows, building organizational ontologies, and embedding Foundry as the operating system of the enterprise. Before we get started, I just want to give a big thank you to Ranger for putting on a great event, and go Blue Jays. All right. So pilots are failing to gain adoption. In July, we all saw the MIT published report about how 95% of enterprise AI deployments fail, despite $40 billion in investment. We believe Palantir deployments live in the 5%. Enterprise AI isn't failing because of the technology. It's failing because how enterprises are attempting to deploy it. We've seen the same story across industries, pilots that excite stakeholders, but workflows that do not scale. Today, I want to show you how we break this cycle, why building on a foundation of trust and the ontology is what separates the winners and losers in enterprise AI. Foundry is revolutionizing how organizations do business. For too long, companies have let SaaS tools dictate process. But when process is driven by industry best practice, there's no competitive edge to gain. Foundry flips this. Software that molds to your process, unlocking differentiation. Some of the most celebrated Foundry deployments involve these 0-to-1 workflows, brand new capabilities that solve problems in novel ways. Palantir deployments excel here. Rapid proof of concepts that deliver immediate value, solving hard problems for their customers. But what happens when the implementation engineers leave? Most organizations are getting stuck scaling. That's why we approach a deployment. We don't just deliver 0-to-1 and build for speed. We always have an eye for where our partner wants to be in the future state. How do we enable 1 to N? The reality is that many pilots fail to scale at large organizations. They're built for one geographical region, using ERP data from one source, typically addressing a singular business unit. The value from the initial use case is real, but when the organization tries to scale it globally, they hit walls. Multiple ERPs, inconsistent logic, different data standards. This is a big reason why MIT found that only 5% of enterprise AI deployments succeed. Now, some of you might be thinking, that's why you build an ontology. And you'd be right if large organizations could do it consistently on a global level. What can happen is a sprawl of point solutions, different teams building overlapping objects on the same data, duplicating compute, and creating silos inside the platform. That's what we call the use case trap. Every organization starts in the crawl phase, building individual use cases to prove the value and potential ROI of Foundry. Without a strategic establishment of the global ontology, organizations get stuck in the use case phase, building disconnected use cases that begin each build phase with fresh data engineering. You can still drive extreme value in the use case phase, but the exponential value comes from the underlying ontology is your organization's digital twin, and the use cases are built in an interconnected web, providing compounding value. Even in Foundry, large organizations can get stuck in what would be considered as multiple ontologies. By global ontology, I mean a series of core objects encapsulating all organizational information interconnected on primary keys. A digital twin, but so much more than that. It's the foundation for everything to be built on in Foundry. This becomes increasingly difficult, though, the larger the organization. Palantir customers are the only ones consistently deploying enterprise AI because of the power of the ontology. But it still takes time and discipline to deploy global ontology at large organizations. The alternative to the use case trap is to build the global ontology early in the Foundry journey. This enables organizations to skip to the run phase, use cases plugged into validated, shared data, actions captured across the organization, feedback loops established, no data reentry. Building once for long-term sustainability and scalability, enabling true enterprise AI with your underlying source of truth. Take global manufacturers as an example. Through acquisitions, they've ended up with hundreds of plants across every continent, multiple ERP, CRM systems. Historically, global supply chain visibility was impossible. With the global ontology established, insights into the complexities of a global supply chain become a natural output. Pricing on material receipts instantly verified against purchase order agreements, materials harmonized across systems, Tariff changes reflected in real time. What was previously impossible becomes a part of day-to-day operations. Without it, you have localized use cases that don't interconnect and give operational level insights in real time. When the European team builds an exceptional procurement workflow, the North American team can't use it because data and schemas have not been standardized. Each individual use case starts at the data engineering phase. One of the main reasons why AI deployments fail is that use cases are not built on that shared ontology. Each use case solves a local problem, but when the data is inconsistent, end users lose confidence. One wrong number in a workflow, and trust in both the tool and the data evaporates. This stalls adoption across the organization. Trust in the underlying data is key to digital transformation. Establishing a global ontology is how you establish trust in data. Validation is essential. Different ERPs, CRMs, and data sources all calculate differently. Without standardization, every new use case requires new data engineering and validation, extending build times and risking a deterioration of trust and data quality. Your core objects act as a turbocharger on development speed. You get to skip the data engineering and validation phase for a majority of your future workflows. You just plug in new use cases to your ready-built ontology. So, back to global manufacturers. They typically empower business units to build their own use cases. Without a shared ontology to work off of, each team creates their own version of localized plants, suppliers, materials, et cetera, in siloed ontologies. This results in unnecessary compute costs, conflicting logic, and extension of build timelines due to the data engineering and validation phase necessary as part of each new use case. Manufacturers need a global view of their supply chain spread across disparate systems into core object sets. In one case, we inherited a pipeline that contained 400 plus nodes as the pilot use case was expanded upon. The problem was this accounted for only one ERP and one SRM. They had 10 plus, and all different join conditions with various SRMs. An attempt to integrate other ERP data at the beginning of this pipeline had caused join explosions and extensive compute costs. Dropped duplicates, transforms littered the pipeline. We unpacked these pipelines into a scalable architecture, modularized pipelines based on ERP and SRM data with matching output tables to union together, making the backing tables for the core objects we created. This step required a significant amount of trust with our client to take a strategic step back to establish a scalable architecture and accelerate any future workflows building these core objects. So how do we end up establishing trust in that data? It's the validation. Working with key points of contacts through the initial validation of the data to identify key issues and solve for the edge cases before it gets into end users' hands for deeper validation of that data. To achieve this, we built a dynamic dashboard and workshop to help with the validation process. This process helps us work with end users on what they need out of an end product dashboard and report generator while working with them to build the trust in the underlying data to use the tool to make better and faster decisions. To build an ontology, you have to break the business down to first principles. What are the core objects, people, assets, contracts that drive the work that actually gets done? From there, we work our way up through core organizational objects, asking, how do these objects link together? What operational actions are needed? This is how you build the ontology, a living map of the organization itself. In the process, you uncover and encode complexity. The ontology gives your data logic and makes it usable. The ontology is the data refinery. Without it, using an organizational LLM is like pouring crude oil into your car and expecting it to run. With the ontology, an organizational LLM can be the jet fuel used to accelerate workflows and deliver real, actionable insights that help end users with decision making. Documenting all of this structure is critical. There's rarely going to be a system subject matter expert at large companies. You'll have subject matter experts for each ERP, each SRM, each CRM. So part of our forward deployed engineer responsibilities are being an investigator. Documentation is how we record our findings, providing evidence of how the organization functions. Years into Foundry deployment, manufacturers typically still don't have definitive supplier lists. Multiple systems and manual migrations over the years leave duplication across systems with conflicting data. By unpacking the business logic of each ERP, creating a single source of truth powering the supplier object set, we establish which codes and which systems link to which suppliers. From there, you can envision multiple supply chain workflows that can integrate this data into LLMs that can answer and source the data for key questions that used to take people 10 minutes, sometimes hours, sometimes days to find. You can now see in real time sourcing trends and the largest volume suppliers on a global scale. And this is how it enhances the employee. It is key to frame efforts to deploy enterprise AI as a way to enhance the employee's day-to-day, to remove the work that sucks. Digital transformation is about people, not just the technology. The human side of establishing enterprise AI is eliminating things like redundant reporting, manual data entry, time spent searching instead of deciding. The goal of enterprise AI should be to empower the workforce to do more with less, to enable the organization to scale sustainably without ballooning teams, adding complexity and contributing to the margin erosion. Human AI teaming means data at your fingertips, eliminating redundant tasks, AI agents suggesting, humans focusing on judgment and decisions. At global manufacturers, purchasing teams are buried in data, trying to pull together and reconcile reports from multiple systems and hunting for answers in scattered data. A majority of time spent chasing information. By establishing a global supply chain ontology, we're able to make standardized reports or aggregations that used to make decisions permanently visible. End users are able to find what they need instantly, or even query an organizational LLM on top of the ontology. We are enabling purchasing teams to spend more time on negotiations and making faster and better decisions. When enterprise AI is framed as a tool rather than a threat, adoption of the tool increases and enhances adoption at scale. According to MIT's Gen AI Divide report, only 5% of enterprise AI pilots succeed. But even with Foundry, workflows can fail to scale if organizations don't establish the right architecture early. Establish the ontology, validate the data, revalidate the data, and then validate it again. Trust and discipline at the foundation prevent chaos later. Pilot pipelines often balloon in complexity as new requirements appear. We need SRM data, we need purchase order information, material data, joins stacked on top of joins with a tangle of logic, brittle, expensive architecture, and nearly impossible to scale. This is often critical as part of the pilot process, though. You're building for value at speed, but this can't be long-term architecture. These pipelines need to be unpacked and optimized for scale. Instead of piling logic on top of logic, we modularize. SRM parts go into a cross-reference table, then a parts master data set that backs the object. ERP data is cleaned, standardized, and unioned after matching schemas. Every new source plugs into an architecture that anticipated growth from the outset. When we partner with our clients, we make it clear we deliver the 0-to-1 workflows, but we keep an eye towards what N would look like in their future state. We design architectures that continue to ingest more data, more systems, enabling more use cases. One of the advantages of the forward deployed model is that we get to understand the business at all levels, from the executive vision to the operator's workflow. And we build solutions that work for both, for the short term in the use case phase and the long term in the operating system phase of Foundry. The enterprise of the future will be agentic. Routine tasks automated or handled by agents that hand off higher value decision-making to humans. These agents live on top of the ontology. They're going to be the hyperscaler for organizations. The ontology enables you to build in these LLMs, agents, models on top of real-time data aggregated from all sources. All of the cool AI workflows stakeholders ask for can be built in timelines never experienced before in software development. Agents are going to supercharge your employees and multiply their capacity, and doing it in a way that still feels like less work with more satisfaction. The organization gets to protect profit margins as they scale and do more with less. And because every decision captured in Foundry links directly to its outcomes, organizations and employees can see cause and effect, learn from the past, and make better decisions moving forward. This feedback loop is what transforms day-to-day operations from reactive to proactive. This is what it means to cross the Gen AI divide. A scalable ontology underneath, interconnected workflows that remember and coordinate, organizational LLMs trained on internal validated data, and agents eliminating redundancy so people can focus on what matters. That's how you scale enterprise AI. AI is not failing. Deployments are. Too many organizations chase point solutions just to say they're exploring AI to satisfy boards and investors. But tomorrow's winners are embedding AI in the fabric of their business today. They don't think of themselves as a manufacturer or a logistics company. They think of themselves as tech companies that make or move things. As Foundry experts and engineers, our jobs aren't just to solve problems in new ways, the 0 to 1 wins. It's to keep our eye on the larger goal, scaling from one to N, enabling true digital transformation, and making enterprise AI real, embedding Foundry in the organization as its operating system. That requires anchoring on the ontology, building adaptable and interconnected workflows, empowering end users, and identifying redundant process. And most importantly, building trust between the business and the technology. This is how we build AI that lasts, and this is how we win together. Now, we obviously can't show any client data or anything in Foundry whatsoever, but we wanted to show some Foundry today. So on my personal stack in the past 2 weeks, in the limited time that I've had, we wanted to just put together something that looks like a connected operating system built on top of a core ontology. So to that end, we're going to show some short clips of NHL-based workflow, harnessing the modularity of Foundry to develop an end-to-end operating system for any organization. What does an operating system in Foundry look like? Really, whatever you want it to. You're going to see these workflows hosted in Workshop, but with an OSDK, we can build React-based forward-facing applications for enhanced user interfaces. Sports is a great example on how organizations can leverage data to win. That's what we want to do for our clients. So let me introduce you to the 2026 Stanley Cup champion Toronto Maple Leafs. Fingers crossed. The Toronto Blue Jays are changing the vibes in the city right now. So you can see all these workflows are split by function. All are built on a shared ontology and interconnected. And we're going to start with a schedule. So we can see that we've got a flight into Buffalo today to play the Buffalo Sabres. And actually on the schedule, you can see that we've got a back-to-back, meaning we play tomorrow night as well. So we see we have a hotel booked, and we've also got a flight out of Buffalo back to Toronto booked because the end of the back-to-back is a home game. So they're playing in Buffalo tonight and then Toronto tomorrow. So to prepare for this, we're going to set our lineup. And Buffalo's not a very physical team, so we're going to put in our rookie, Easton Cowan, and we're going to trade him for Calle Yarncrow. The metrics at the top are cut off somewhat, but you can see that once we put in Easton Cowan for Calle Yarncrow, the average age of the team goes from 29.25 to 28.5, and the average weight goes from 210 pounds to 208 pounds. This is just lining up your data in a way that you can actually just get these insights right away rather than asking an analyst to get it for you. So from there, we can click into player salaries, and we can see we have roughly $500,000 in cap space currently. You can see his contract clauses like no trades or no movements, and you can see players' cap hit, how many years they have left on their contract. From there, we click into salary negotiations. The Leafs have 17 expiring contracts this year, and 6 of which are on their current roster. We'll click into Nicholas Robertson and see correspondence with his agent, Pat Brisson. We can see he's requested a trade the year before, accepted a one-year contract this year, and rejected an extension of that contract. In the cutoff metrics on the top, you would see projections for around $25 million in cap space for 2026 currently. So we want to clear a little bit of that cap space while getting better on faceoffs. Max Domi's our worst faceoff taker and makes $3 million. So we're going to propose trade for Casey Cizikas of the New York Islanders, another center making $2.5 million. Similar player making a little less money, but better defensively and on faceoffs. I select both players, and then advanced statistics for 2024 become available for analysis. But there are so many data points, it may take an analyst a couple of hours just to evaluate the players. Oh boy. Oh no. Is there any way to get back to that? You can't put it to the timestamp? Dang, that's my bad. Hit the thing too early. Anyway, what you would see from that trading workflow is that instantly it popped back up to us saying that Max Domi has the New York Islanders on their no-trade list. Right? The Ottawa Senators, about 2-3 years ago, they made a big mistake in trading one of their players to a team that was on the players' no-trade list. That mistake cost them a first-round pick. With a Foundry operating system, those mistakes never happen. Our assistant's recommendation here was no trade. The Leafs would lose more offensive value than they would gain in defensive depth, and Domi's no-trade clause makes the deal impractical. In this trade workflow, you could also open up to see Domi's full no-trade list, and we can see that the New York Islanders are listed on that. Now, when we do an analysis of our team performance on where we can be better, when we click into team stats, you'd see team stats for 2021 to 2024 in all situations, 5-on-5, power play, penalty kill. But again, this is a ton of data for anyone to digest in action. So we end up asking our AI assistant for some insights on team stats. And you see some key insights with a summary of the Leafs have regressed in possession and puck management, with offensive output and physical play also declining in 2024. Defensive metrics are mixed. The coach should prioritize puck control, transition support, and offensive zone time to reverse these trends. From here, we'll schedule a practice for the team for today in Buffalo to work on some of these suggestions. If anybody's watched the Leafs in the past few years, they would know that those recommendations by the AI assistant are exactly correct. Now let's dive into player stats after that. Our captain and best player, Austin Matthews, had an off year last year. But again, there's so much data to go through from all situations in those years. So let's ask for some insights. The AI assistant gives us the conclusion that for Matthews to return to his top goal-scoring form, he should focus on his finishing touch and maximizing chances in high danger and rebound situations. So similarly, from there, you can schedule individual player practice for Austin Matthews to work on his shooting after the team practice ends today. And then after that, you're going to see it go back to the schedule, and you see those practices on the schedule. Now, there's tons of other individual workflows that you can build, but this was in what little free time that I had in the past few weeks. And you can envision a player application where Austin Matthews gets that schedule built, and he sees automatically on his phone that, okay, great, I've got to practice today with this coach at this time at this location. Now, that's what an ontology-enabled operating system enables for you. It has never been faster to drive value at organizations, and that is through Foundry. We just have to ensure that while we build all the fun 0-to-1 workflows, we have an eye to the desired future state of the organization. And here, this part is going to show you the Austin Matthews. So we have 2021, 2022, 2023, 2024 stats, open up insights, and this is where it tells you what Matthews needs to work on. So I'll leave this playing in the background, but I think we've got 4.5 minutes for questions.